Okay, so we have started our new book, which is Kaleidoscopes, Hubcaps, and Mirrors. It's mostly a geometry book. So we'll be doing a lot of things about symmetry. We'll be doing a lot of things about congruent angles, congruent triangles, similar triangles, that kind of thing. But what we're going to start off with is reflection symmetry. So students will understand the properties of symmetry, recognize and describe reflection, rotation, and translation symmetry, and then use tools such as mirror or mirror to analyze designs to determine the reflection symmetries. Success criteria after this section, what we hope you can do is define symmetry, reflection symmetry, and line of symmetry, and then use a mirror. Probably won't have a mirror, but a mirror to find all the reflection lines of symmetry. So first of all, if you look at the butterfly down here, you notice that the two sides are exactly the same. So if you were to take the butterfly, if it was on a piece of paper, and if you were to take this side and fold it over so that this side laid exactly on top of this side, you would see that both of the sides match up. And that's just what symmetry is. So this is an example of reflection symmetry. All the lines over here are the same as all the lines over here. All the coloring is the same. Everything is exactly the same. This right here is an example of rotational symmetry, and we'll talk a little bit about that in the next flip chart. But basically what you need to know is that symmetry is a balanced pattern. All right, if you think about a heart, you know, where you fold the paper in half, and on the edge that's folded, you cut out half of a heart. When you open it up, you get a whole heart. Well, this line right here would be the line of symmetry, because this is where you can fold it so that both sides match up exactly. Okay, so reflection symmetry is just if you were to fold a mirror up halfway through, then you could see this part reflected over here in the mirror, and it would match what's behind the mirror. So this is your line of symmetry right here, and this part over here and this part over here are exactly the same. So basically your two vocab words: symmetry where you see a reflection, this is reflection symmetry; symmetry where you see a reflection of the image you are looking at; and then line of symmetry divides a figure into halves that are mirror images or identical images. So one of the things that we should note is that in some cases there's only one line of symmetry. So if you were to look at this design here, we can see that the only line of symmetry is this one right here. Now, some people were asking earlier, well, why isn't this a line of symmetry? Because if I fold this part over, it matches this part exactly. But the one thing that you have to notice about reflection symmetry is that the half figure and its reflection have to have the same size and shape as the original figure. So this is really important to know about reflection symmetry. Both of the two pieces have to add up to give you the same thing that you started with. So if we were to fold on this line right here, this piece right here folded over to this piece would not give us the same. So we would only have these two pieces right here. But the other thing that you have to know is that it's not always necessarily just going to cut it in half. And we'll see that, an example of that a little bit later on. So this line right here is not a line of symmetry because this side would be bigger than this side, and the sides have to be equal in order for it to be a line of symmetry. If we look at B, okay, take a couple of seconds, pause the video if you need to, and see if you can figure out where the line or lines of symmetry would be for B. Okay, so if you look at B, you'll notice that it has two lines of symmetry, the one that goes vertically up and down and the one that goes horizontally across. Okay? If we were to fold it in half, both sides would be the same side and they would match up exactly. And same thing if we were to fold it on the horizontal line. Top and bottom would fold up exactly and they would match and they would be the same size. Okay? If we look at C and D, take a couple of seconds to see if you can come up with the line or lines of symmetry for both C and D. Okay, if you look at C, you notice that if you were to cut this down the middle here and cut this down the middle here, these two would both be lines of symmetry. So if you can imagine folding it on this line right here, folding from here to here, putting this part on top of this part, those two would match up. And the same thing would be true if you were to fold that paper on this line. These two pieces would match up. And I had some people in class ask, well, couldn't I cross this on the diagonal? Well, or sorry, wouldn't there be a line of symmetry on the diagonal? Well, the problem with that, there's a couple of things. This triangle right here is not facing the right direction to match up with this figure right here, okay? So if you were to fold this one over, this triangle would be facing a different direction. It would be facing this way. Okay, so the triangles are facing the wrong direction here. And so some people asked, well, we talked a little bit about how could we make this symmetric. If we wanted it to be symmetric, one of the things that we could do is we could turn these green triangles and turn them inward. We would also have to change their color because if you notice, these triangles are purple, these triangles are green. So if we were to fold this over, the purple would not match up with the green. The other thing that we could do is some people suggested, well, couldn't we just take out all these triangles altogether? And so that is another option, would be to remove all the triangles. The small triangles are on the outside. And then that would be a line of symmetry. But as it is right now, this line right here is not a line of symmetry. On D, if you look at this one has no line of symmetry. There's a couple of reasons why. The first thing is that we have the arms and the legs. Okay, so we've got the arms and the legs and the head on here that keep it from being symmetric. So if you were to fold this side on top of this side, they wouldn't match up. The head wouldn't match up with the feet and the arms wouldn't match up with the no arms over here. So even if we took those off, okay, so imagine that those are gone. You don't have those arms anymore. Okay, so imagine that these are gone. Okay. We still wouldn't have a symmetric figure. And the reason why is because, oops, missed the head. See if you can spot it. The reason that this would still not be symmetric. A lot of people thought if we just cut it down the middle, it would be symmetric. But if you look, this corner here is not the same as this corner here. So even if we remove the head and the arms and the feet, it still wouldn't be symmetric because this one has the double line and this one has just the triangles in the corner. So no lines of symmetry. If we look at these, see if you can take a couple of minutes and find the lines of symmetry on these. Okay, so these would be the lines of symmetry for these figures. It helps if you have like a little mirror that you can use to set along these lines so you can see that when you put this side with the reflected side of the mirror that it gives you the exact same figure that you started with. The parallelogram has no lines of symmetry. If you were to fold it like this side would stick out farther than this side and this side, sorry, this side here would stick out farther than this edge and this corner here would stick out farther than this corner here. The reason that this one has 3 lines of symmetry is because it's an equilateral triangle. So all 3 of these sides are exactly the same length. And so if we were to fold this along this line, these 2 sides would match up. If we were to fold it along this line, these 2 sides would match up. And if we were to fold it along this line, these 2 sides would match up. The reason that this one only has 1 is because this is an isosceles triangle. So only these 2 sides are the same. If we were to try and put a line of symmetry here, this side over here would not be exactly the same as this side over here. So this is the only line of symmetry in an isosceles triangle. We've already talked a little bit about these. So the homework is just page 15 to 16. I've got those as PDF files on the website. If you can print those off or if you need a copy, let me know. I can either email it or send a hard copy somehow. But page 15 and 16, 1 through 9. Number 1 is basically just asking which letters of the alphabet have lines of symmetry and where those lines are. And then 2 through 9 is giving you some figures to draw the lines of symmetry. Now some of those figures don't have any lines of symmetry at all, and some of them have more than 4, so you have to look really hard for some of those lines of symmetry. If you have any questions, let me know. Hope you're doing well. Good luck. Let me know if you need anything.